Hello everyone. So next is addressing mode. So previously we have seen that in the instruction, right, after opcode, how many address fields are there, right? So that we have seen previously, and in this we will see that the address field, particular address fields, right? How you will get the address of your operand, right? You will get direct operand here, or you will get the address of the operand, or you will get the address, and from that address again you will get the address, and then you will get the operand, right? So this is the addressing modes that we are going to see in this. So the addressing mode specifies a rule for interpreting or modifying the address field of the instruction before the operand is actually referenced. This thing I have explained you here. Now the computer use addressing mode techniques for the purpose of accommodating one or both of the following provisions. One, to give programming versatility to the user by providing such facilities as pointer to memory, counters for loop control, indexing of data, and program relocation. Right. So you can specify the address, and then from that address, it will get the operand. Second is to reduce the number of bits in the addressing field of the instruction. Suppose if you fix this length, right, then it will be difficult and your instruction length will be high. Rather than that, if you just specify the location, and if that location gives you sequential operand, or it may possible that the operand size is large, then that can be accommodated, and at the same time you can reduce the size of your instruction. Okay, and it gives flexibility for writing programs that are more efficient with respect to the number of instruction and execution time. Now next, uh, about instruction cycle, right? Instruction cycle means the time for executing one instruction. So they are divided in three major phases: fetch, decode, and execute. Okay. Now the program counter registers hold the address of the next instruction to be executed, and is incremented each time an instruction is fetched from memory. Okay. So what program counter holds? It holds which instruction next you need to execute, right? An instruction register IR holds the current executing instruction, right? The instruction that you are executing right now, that will be stored in IR, and program counter stores next instruction to be executed. Okay. Next is decoding. So the decoding is done in the next step, and it determines the operation to be performed, and the addressing mode of the instruction, and the location of the operands, right? So that is done in the decoding phase. And last is execution. In that, the computer then executes the instruction and return to step 1 to fetch the next instruction in the sequence, right? So fetch, decode, and execute. Then let's see this instruction format with mode field. So we have opcode means operation, we have mode and address, right? So the operation code, opcode, specify the operation to be performed, which operation you need to perform. The mode field is used to locate the operands needed for the operation, right? And there are many, or or they there may not be address field in the instruction. If there is an address field, it may be designated a memory address or a processor registers, right? So this address can be memory address or a processor registers. Hmm. Then addressing mode. Which mode is this, right? That we have seen here. Which mode? of addressing. Then the address will be specified, right? Mode will tell you about this addressing field, which type of addressing mode it is, right? It is implied mode, direct addressing mode, what, right? And using this, you can get your operand, right? Or you will get address from here, from where you can get an operand, or you will get another address, and from that again you will get address, and then you will get your operand. Okay, or it can be a register address. Okay, now let's move to the addressing mode. First is implied mode, right? So in this mode, the operands are specified implicitly in the definition of the instruction, right? Operand is specified in the instruction itself. Example, complement accumulator. So you just need to specify complement, right? And where is your operand? Your operand is already in accumulator, so no need to specify it, right? You just, when you use this complement, right, it will take the value of complement accumulator and complement it, right? So we have not specified the operand here, just we have specified the operation. And this is no address field instruction, because there is no address is required, we have not specified the address of operand. All register reference instruction that use an accumulator are implied mode instruction. Okay. Then zero address instruction in a stack organized computer are implied mode instruction, since the operands are implied to be on top of the stacks, because in that also we are not specifying where your operand is, we are just using push and pop operation, right? And whenever we need to perform any operation, right, what we do, we just specify that operation add. So in that case it will just pop two values from the stack, perform the operation, and again push it, right? So that is implied mode addressing mode. The next is immediate mode, right? So in immediate mode, operand is specified in the instruction itself. Here, the operand is specified in the instruction. In previous case, neither address nor the operand is in the instruction. We are just using the operation code. But here, the operand is specified in the instruction. So we have an operand field rather than an address field in immediate mode. And this is useful for initializing register to a constant value, right? So in such case, this immediate mode is useful. Next is register mode, right? So in this, operands are in a processor registers. Whatever operands you want that are in registers. Then address field of an instruction specifies a process registers. So as I told you that address field of the instruction can specify memory or registers, right? So in this case, address field of instruction specify processor registers in register mode. Specify what? Processor register. It will tell you, get the operand from register R1, get the operand from register R2. Likewise, the particular register is selected from a register field, right? Which is actually an address field, we say, right? But as we are mentioning register, we will uh, tell it as a register field. K bit field can specify any one of 2 raised to k registers. So if you have 3 bits, then you can specify 8 registers, any of the 8 registers. Then next is register indirect mode. Okay, register indirect mode. Previously it was register mode, now register indirect mode. In this, instruction specifies a register in the CPU whose contents give the address of the operand in memory. So in previous case register mode, The operand is stored in the registers. Operand is in registers, right? But in this case, register stores the address of the operand, not operand, right? So once you specify the registers, right? Suppose I specify register R1, right? This is the R1. In previous case, directly from this register, I will get the operand. But in this case, register indirect mode, once I will specify the register, from this I will get the address of the operand. If this is 100, then this is the address 100, right? And from that I will get the operand. So that is a register indirect mode. The advantage is address field of the instruction uses fewer bits to select a register than would have been required to specify memory address directly. So your physical address, right? It may have a more bits, right? Suppose your physical address has 32 bits to specify the address. Your register length must be 32 bits. Register length must be 32 bits. But suppose you have only 8 registers R0 to R7, then in instruction address field, you just require 3 bits because now you will specify from this registers R0 to R7, and from that register you will get 32 bits, which is a main memory address, right? And from that address you will get the operand. If this is not the case, then 32 bits I need to specify here, right? 32 bits. Okay. So now you can see we have reduced the size. Okay. So this is register indirect mode. Next is auto increment or auto decrement mode. So it's similar to register indirect mode, except that the register is incremented or decremented after, right? In case of increment, after or before its value is used to access memory. So it is auto increment decrement mode. So it's a register indirect mode only. The only difference is register is incremented, register is incremented or decremented after its value is used to access memory. Okay. When the address stored in the register refers to a table of data in memory, it is necessary to increment or decrement the register after every access to the table. So sequentially, if you are accessing, then after accessing first entry, you want to go to second, you want to go to third, likewise. So in that case, this auto increment decrement mode is useful. Okay. Then direct addressing mode or an indirect addressing mode, right? So in direct addressing mode, effective address is equal to the address part of the instruction. Your effective address means from where you will get the data, that is equal to the address part of the instruction, right? So effective address is defined to be the memory address from obtained from the computation dictated by the given addressing mode, right? It's a memory address which you obtain, right, from given addressing mode after calculating your address. Just remember that your effective address is a memory address after the calculation, right? In direct, effective address is equal to the address part. In indirect address mode, the address field of the instruction gives the address where the effective address is stored in memory, right? So you need to perform some addition with respect to some registers in indirect addressing mode, right? Rather than directly giving that your operand is at this place, at this address, right? In indirect address mode, right? What we'll say? your operand is 200 from your index register, right? Or specific registers. So we are giving some reference in that. So ultimately, after adding value in index register plus your address field, it will give you the effective address, right? So one example I have given for indirect addressing mode, right? So based on some reference, you will get the value in address field, right? Your address field in the instruction is a reference to something, not direct address. To calculate the effective address, you need to add this value to some specific registers, right? So this is an indirect address mode. Direct address, from your address field directly you get the effective address. Okay, but indirect, it's give you a reference. Mhm. So next is relative address mode. So content of PC program counter is added to the address part of the instruction in order to obtain the effective address. So this is called a indirect addressing mode, right? Your PC, right? What the content of the PC is added to the address part of the instruction. What PC stores the address of the next instruction. Okay, so we need to calculate effective address in this case. So effective address in this case is your PC value plus address from your address field. Okay, the position in memory is relative to the address of the next instruction. So you see, you are specifying the address in the address field. What it says, suppose it's a 20. So it says that the effective address is 20. Okay, if it is a byte, effective address is 20 bytes after the next instruction. Suppose if next instruction is 100, then after 100, it's a 20 bytes, right? At that place, 120, you will get the address of the operand or operand. Okay, that is a relative address. Relative, right? Related to what? Right now, PC. Okay, let's see the example. Suppose your program count is 825. Address part of the instruction is address part of the instruction. This is your address field, that is 24. So your effective calculation is 826 plus 24. Why is this 826? Because right now the program counter is 825. When it fetches the instruction, right? After fetching the instruction, it knows the mode and all. So after that, it will increment the program counter, that is 826, 826, right? Then it will know that this is the addressing mode, this is the instruction and all. And next instruction is 826. So now 826, which is your next instruction, on that I am giving the reference, that is 24. Okay, so plus 24, that is 850. This is the effective address from where you will get your operand. Okay. Next is index addressing mode. This index addressing mode. So content of the index register is added to the address part of the instruction in order to the effective address. In previous case, relative address mode, the content of program counter is added. Here, the content of index register is added. Okay, to obtain the effective address. So in this case, effective address is index register plus your address. In previous case, PC plus address. The address field defines the beginning address of a data array in memory. Right? So if it does not include address field in its format, the instruction converts to the register indirect mode, because now we are accessing from registers, right? from particular register because there is no address field. So what is your effective address? It is index register from where you will get the operand. So you are getting operand from register. So that is register indirect mode, right? Or you will get the address from that register. So that is a register indirect mode. Okay, so it gives you the address of the operand. Effective address gives the address of the operand where the operand is. Right, so effective address, this give you address where the operand is. Okay, so if this is not here, then index register. In that, the address will be there, which gives you the operand. So it is similar to register indirect mode. Okay, then base register addressing. Next is base register addressing mode. In that, this content of the base register is added to that part of the instruction in order to obtain the effective address. Right? So effective address is base register plus address. In index register plus address. In relative, program counter plus address. We have seen relative address mode, index address mode, and base register address mode. Right? This is used to facilitate the relocation of program in memory. So what you need to do, right? This address field, this is reference to this base register. So once you change this base register, right, you can relocate your program. Now it will start from that base register. So it will be easy to relocate your program in memory, right? So if I say that this is my program and this is the base address 100, right? And the program is starting from 0 to 511, 0 to 51. So whenever I need to access, I will add this 100 plus 0. So this is the first byte, then 100 plus 1, then second byte. Likewise, I will access. Now I want to relocate this program. So now the new location is suppose 500, and from 500, 0 to 511. I have relocated to this memory address. So what I need to do? Just I need to change the base address, right? Once I change the base address, right, I can similarly access the program. Okay, so relocation is easy in this base register, or it facilitates the relocation of program. Okay, so we have seen the addressing mode. Some are the direct addressing mode, some are the indirect addressing mode. So in indirect addressing mode, you will find out the effective address, right? And sometimes you add your address field into PC, sometimes in index register, sometimes in base register, right? In direct addressing mode, you will get the direct address. Okay, and we have seen some another mode as well, that is implied mode, immediate mode, registered mode, right? Register indirect mode, auto increment, and auto decrement mode, right? So this all about addressing mode. So in next video we'll see the example of it.